皆さん、こんにちは。僕はミスタースーです。今日のビデオは前近です。一緒に始めましょうよ。Alright, so asymptotes end-to-end behavior. Interesting topic. So let's just start off with what asymptotes tell us. We got vertical and horizontal that we're going to talk about. There's slant also, but don't worry about that for now. So let's begin with vertical asymptotes. What are they? What do they tell us? Well, what they tell us is where the function is undefined. So I'm just going to spell this out for us. It is where the function is undefined. So what does undefined actually mean? Well, it basically means that the function makes no sense there, whether it be dividing by 0, a negative log, or something like that. Something that literally does not compute. We'll go over some of that later on here, or you can review it yourself. And remember that this is also then related to domain, because domain tells you where the function is defined, but this tells you where the function is not defined. So they're complements of each other. Math talk for opposites, basically. All right, horizontal asymptotes. What they tell us is what happens at the infinities. What happens at the far left and far right of the graph. And this relates directly to end behavior as well, because basically the end behavior tells us the behavior of the function at the ends, which is the far left and right. And the end behavior is more of just a statement that tells us that, and the horizontal asymptote is more of an equation that tells us that. So they're essentially the same. So left and right is the ends, and what happens is the behavior, hence end behavior. Shocker. Alright, so let's actually work with them. Vertical asymptotes, they're kind of easy to work with in the sense that you just gotta find where's the function undefined. So in this case, where's the function being divided by 0? So let's figure out where does x plus 3 equal 0. That happens when x equals negative 3. Therefore, the vertical asymptote is the equation x equals negative 3. What I see a lot is people write VA equals negative 3. So this, don't do that. That doesn't make any sense actually. That's called sad, because wrong. So don't do that. That doesn't make sense. Write the actual equation itself. Alright, for logs. So log of anything, remember, log base k, so k is any possible base. In order for that to exist, the domain is where box is greater than 0. So there's going to be an asymptote, a vertical asymptote, when box equals 0. So we got to figure out where does that thing equal 0. By that thing, I mean the thing inside of the log, x minus 2. We can easily see that this happens at x equals 2, so we can say that the vertical asymptote is x equals 2. And that's it. And again, don't write VA equals 2. Just don't do that. Sadness. Okay. F of x equals ln of x minus 2 over x plus 3. Let's try this one. Well, we know that x has to be greater than 2. That's the domain of the numerator. Domain of the denominator is, well, or the vertical asymptote for the denominator is x equals negative 3. But x is greater than 2. If we have that restriction, then that kind of overrides the whole x equals negative 3 thing. So essentially, that part becomes irrelevant. And we can just use the x is greater than 2 part to say that the vertical asymptote, so that's the domain, but basically we can tell then that the vertical asymptote is just x equals 2, same as the last one. Alright, now let's look a little bit at horizontal asymptotes. What happens when x gets really big in the positive and negative direction? if you're looking at this in a calculus sense or just a preview for next year, this notation, limit as x approaches plus or minus infinity, you'll see that that's the abbreviated version of this. So let's actually do that then with this function. Let's look at a table of values that tells us that information. If we look at the table, as x gets really big in the positive way, we see a trend going on, right? So looking at x getting really big positively, we see that we have the f of x value getting really close, getting extremely close to 0. That's what it means when it gets extremely small. And if we look in the negative direction, we see the exact same thing happening. It is also getting extremely small. And extremely small, what that really means, again, is just this is approaching 0, getting towards 0. Because yeah, there's a negative and there's a positive there, but basically a small number is not negative, a small number is 0. A fraction, getting really close to 0. So we can say that the horizontal asymptote is y equals 0. Again, do not write ha equals 0. I will mark that wrong. Most teachers will, and that's sad. So sad face. Alright. So let's kind of look at this algebraically and make sense of it that way. So we're basically getting 1 over a big number plus 4. And that's going to be approximately, well, 0. So that's kind of like, let's imagine your chances of winning the lottery, 1 over a big number, because you're like a 1 in a thousands, millions chance of winning, which is basically 0. So you can kind of logically think about it that way, because 1 divided by a big number, pretty much that. So that's essentially what a horizontal asymptote is, and behavior, essentially same thing. You just write as x approaches infinity and negative infinity, y approaches 0. So now let's look at here. We see here that this number is getting close to 0.6 with a bar over it. So you see a bunch of 6s repeating. So essentially that's 0.6 with a bar over the 6 because the 6 is repeating. Same thing the opposite way. Exact same number that this is approaching. So what is that as a fraction? That's actually 2/3. So you can say the horizontal asymptote is 2 over 3. Okay, that's interesting. So that means we get basically that numerator and denominator. And let's kind of look at why that's true then. If we have 2 over 3, that's 2 times some big number. And that's 3 times, again, some big number. And then we add 1 to it. So the thing is, these big numbers, they're the same big number, right? So no matter what, those x's are changing the same. They're the exact same number. And so this essentially becomes 2 times 3 over something. I'm just going to put box. So you're multiplying by something. Also, the one basically becomes irrelevant because of how big everything else is. So the boxes can divide out, and essentially we get 2/3. So we don't get exactly 2/3 because of the plus 1, but we essentially do. We're getting close to it. That's why you don't touch the asymptote, you just get close. And it makes sense if we just look at it, because the growth rate in the top and the bottom is the same. It's just the top is multiplied by 2, the bottom is multiplied by 3. Over here, the degree of the numerator is 0. The degree of the denominator is 1. So that means the growth rate of the denominator is greater than the growth rate of the numerator. So that makes sense then why this approaches 0, because the bottom is growing a lot bigger than the top. If you switch that, then you just get infinity. Same idea. Alright, tangent inverse. This one's interesting. if we look toward the right, going way, way right, you can get more points if you wanted to. I just stopped here. This is getting closer to basically, well, pi over 2, because we got that approximate decimal. Almost the same thing. What if we look toward negative infinity? Well, we see a very similar thing. We see that it's getting closer to not pi over 2, but negative pi over 2. It's got the negative of that number, basically. So, we can say that the horizontal asymptote, well, there are two of them. We have y equals pi over 2 and y equals negative pi over 2. If you know the parent graph of this, it also helps. So just going to draw it quickly over here. So got those asymptotes, and it looks approximately like this on the right and this on the left. ご覧いただきありがとうございました。楽しんでいただければいいねして、コメントをして、購読してください。次のビデオに会いましょうよ。